Hi, my name is Jackie Andreka, and I created a new way to detect pancreatic cancer that costs 3 cents and takes 5 minutes to run. However, my story began with tragedy, when a close family friend, who was like an uncle to me, actually passed away from pancreatic cancer. When the disease hit so close to home, I knew I needed to learn more, so I went online to find answers. But what I found shocked me. Over 85% of all pancreatic cancers are diagnosed late, when someone has less than a 2% chance of survival. And to make matters worse, the current test is a 6-year-old test. I mean, that's older than my dad. But also, it costs $800 per test, and is grossly inaccurate, missing 30% of all cancers, and thus is rarely ordered. So, armed with 8th grade biology, I set out determined to find a new way to detect pancreatic cancer. But I had no clue what was in store for me. First off, what I found is when we're looking for these cancers, we're looking at your bloodstream, particularly for these variations in protein levels. And while this sounds really straightforward, it's anything but. You see, you have these liters and liters of blood, which is already abundant in an innumerable amount of proteins. And you're looking for this one small change in this tiny amount of protein. It's next to impossible. It's like trying to find a needle in a stack of nearly identical needles. However, undeterred due to my teenage optimism, or how some people label it, complete and utter ignorance of the entire field of cancer research, I persisted on, and using Google and Wikipedia, I found a database of over 8,000 proteins that are found in your bloodstream when you have these cancers. And with my summer break, I had nothing else to do, and I went through all 8,000 proteins. And finally, on the 4,000th try, when I was pretty sure I was never going to be able to socialize effectively again, I finally found one protein that could work. And the name of this protein was called mesothelin. And it's just your ordinary, run-of-the-mill type protein, unless, of course, you have pancreatic, ovarian, and lung cancer, in which case it's found at these very high levels in your bloodstream. But the key is that it's found in the earliest stages of the disease, when someone has close to 100% chance of survival. So if you could detect this protein, that means you could potentially detect the cancer in the earliest stages, when someone has close to 100% chance of survival. And now the question was, how on earth am I going to detect this protein? I mean, this has been a question that has perplexed scientists for ages. But the answer came in a really unlikely place: high school biology class. And for me, that was the absolute cipher of innovation, particularly with my biology teacher. And one day, tensions between me and my biology teacher reached record highs, so I rebelled how any high schooler would. I stuck in an article on single-walled carbon nanotubes. And these are essentially these long, thin tubes of carbon that are an atom thick, and they're 1/50,000th the diameter of a single strand of your hair. So extremely small. But they have these amazing properties. They're kind of like the superheroes of material science. And while I was reading all these different properties, feeling really sneaky, having it tucked in the pages of my biology textbook, I then looked, and we were learning about these things called antibodies, which are essentially these molecules that are like a lock and key. They only react to one specific protein, in this case, that cancer biomarker. And I was just sitting there when all of a sudden it hit me. You could combine these two concepts and end up with a substance made of carbon that would only react to one specific protein. But also, due to the amazing properties of these nanotubes, it will actually change how electricity flows through it based on the amount of that protein present, and thus indicate whether or not a patient has the cancer. And then I realized I'm probably going to need a lab. I can't do cancer research on my kitchen countertop. And so then I applied to 200 different labs at Johns Hopkins University and the National Institutes of Health, asking, hey, can I work in your lab? Sat back when for all these positive emails to pour in. But then I got 199 rejections, with some professors just tearing apart my entire procedure. However, eventually, one professor, Dr. Anirban Maitra of Johns Hopkins University, finally told me yes. So I went into his lab for this big interview, and after an hour-long interrogation, I had secured my lab space. But just as soon as I started, I realized I was really bad at cancer research. First day, like I accidentally sneezed in my cancer culture, or like I blew them up in the centrifuge. I was just a hot mess in that lab. However, eventually, after screwing up every imaginable scientific procedure, 7 months later, I ended up with one small paper sensor that costs 3 cents and takes 5 minutes to run, making it 168 times faster, over 26,000 times less expensive, and over 400 times more sensitive than our current methods of detection. And they're really simple to make. They're like making chocolate chip cookies, which I personally love. All you do is you take some water, pour in the nanotubes, add antivirus, mix it up, take some paper, dip it, dry it, and you can detect cancer. But the best part is that it so far has over 90% accuracy at detecting the cancer in the earliest stage, when someone has close to 100% chance of survival. And this has broad-spanning implications in the entire field of cancer research, particularly for pancreatic cancer. Because, for example, it could monitor whether or not your therapy with chemotherapy is being effective, or whether or not you're having resistance to that cancer, or whether your surgery for removing the cancer was effective, and far beyond that as well. And so my one hope for this is that it gets out into the public as soon as possible to save as many lives as possible. Because 100 people die of pancreatic cancer every single day. And think, with this test strip, that number could go down. And with more research, we can bring down pancreatic cancer. Because right now, pancreatic cancer is one of the worst funded diseases out there, even though it's the fourth leading cause of cancerous death. So if we bring it to the other levels, such as like breast cancer and prostate cancer, we could potentially be able to change people's lives in how we treat pancreatic cancer. And you can do that. By helping Kerry Irvine, you will be able to make a difference in someone's life through your donation for pancreatic cancer research. Thank you so much for listening, and all the best to Kerry and her 2 wonderful kids.